Hello, this presentation will illustrate the comparative study of catalysis in the Haber process and the Monsanto process. This presentation is being presented by Aragorn number 1, class 513, Yanapat number 7, class 513. Introduction to catalysis. Catalysis refers to the process in which a substance called a catalyst. But what is a catalyst? A catalyst is a substance that increases the rate of chemical reaction without being consumed in the reaction itself. In the right hand side, we can see that the reactant with a catalyst have a much more lower activation energy compared to the reactant without a catalyst. This is why catalysts are essential to many industrial chemical processes, as they lower the activation energy required for a reaction to occur, making the process much more efficient. There are two main types of catalysis: homogeneous catalysis, where the catalyst is in the same phase as the reactant, solid, liquid, gas, and a heterogeneous catalysis, where the catalyst is in a different phase as the reactants. The picture here, there are two pictures filled with solution. The second one shows a homogeneous, and the first one shows a heterogeneous. A heterogeneous catalyst exists in different phases than the reactant. It works by adsorbing the reactant onto its surface, facilitating the chemical reaction. Once the reaction occurs, the products are released or desorbed from the surface. For instance, nickel is used as heterogeneous catalyst in the hydrogenation of carbon-carbon double bond. This is just an example. Homogeneous catalysts are in the same phases as the reactant and form intermediate before producing the final products. The picture on the left side clearly shows how the bonding works. Catalyst bonding to the reactant, release of product, and moving on for another reaction. For example, chlorofluorocarbon CFCS catalyze the breakdown of ozone, contributing to ozone depletions. The Haber process. But before we go into the Haber process, we have to know about Dr. Fritz Haber. He was a German chemist best known for his development in Haber-Bosch process, which he synthesized ammonia. The Haber process is an industrial method used to produce ammonia for nitrogen and hydrogen. He received a Nobel Prize for this chemistry work. The ammonia produced through the Haber process is primarily used in manufacture of fertilizers in agriculture, making the process critical to global food productions. But it requires high temperature and pressure, making it energy intensive and significantly contribute to the carbon emission due to burning of fossil fuel. Even though this is a great idea, it still gives out global warming. Haber process mechanism. The Haber process, nitrogen and hydrogen molecule adsorb onto the surface of the iron catalyst. The bond in the nitrogen and hydrogen molecule break, allowing them to recombine and form ammonia. The reaction is carried out under high temperature and pressure to optimize the yield of ammonia, which can be challenging from both an energy and environmental standpoint.
So this is the Monsanto process. The Monsanto process is used to synthesize acetic acid from methanol and carbon monoxide. It employs a rhodium complex as a homogeneous catalyst, meaning that the catalyst and reactants are in the same phase. The Monsanto process is considered more energy efficient compared to the Haber process. It also has lower emissions due to its more moderate reaction conditions. In the Monsanto process, methanol reacts with carbon monoxide in the presence of a rhodium catalyst. The catalyst facilitates a series of steps, including the oxidative addition and the reductive elimination, which results in the formation of acetic acid. This process is highly selective, providing a high yield of acetic acid with a relatively low energy consumption, making it a preferred method in industrial acetic acid production. So here's a comparative table of the Haber process and the Monsanto process. So for the Haber process, you use iron as a catalyst, which is a heterogeneous catalyst. While for the Monsanto process, you use a rhodium catalyst, which is a homogeneous catalyst. Next up, you can see the chemical equations for the reaction of both processes. And the Haber process uses high energy requirement and you need high temperature and pressure, while for the Monsanto process, you need lower energy requirements. As for the environmental impact, the Haber process produces high CO2 emissions, while the Monsanto process produces much lower emissions. For the Haber process, you get ammonia as the product, which can be used to make fertilizers to grow crops, while the Monsanto process produces acetic acid, which can be used for plastic production and also for food production as well. So here are the advantages and disadvantages of both processes. So the Haber process is very important for global food production due to its role in the fertilizer manufacturing. However, it is highly energy intensive and also very environmentally taxing because it produces a lot of CO2 emissions. On the other hand, the Monsanto process is advantageous due to its high yield and lower environmental impact. So both processes have distinct advantages and disadvantages, and depending on the industry and what product you need, both processes are equally as important despite the environmental considerations. A case study of the Haber process highlights its critical role in supporting global agriculture, particularly in boosting food production to meet the demands of the growing population. However, its environmental impact remains a significant challenge to tackle. In contrast, the Monsanto process has seen innovations aimed at making it even greener, with research into alternative catalysts that may further reduce environmental impact and improve efficiency. In conclusion, catalysts play a vital role in optimizing industrial and chemical processes, and catalysts come in two main types: homogeneous and heterogeneous. So the Haber process is critical for producing ammonia, which is essential for fertilizers, but it comes at high environmental costs due to its energy requirements and CO2 emissions. On the other hand, the Monsanto process offers a more sustainable pathway for producing acetic acid with lower energy consumption and emissions. Moving forward, advancements in catalytic technology will be essential for improving both processes, making them a more efficient and more environmentally friendly process. And here are the references for our presentation, and that will be the end of our video presentation. Thank you very much.